Here we are checking out the June 2024 Chemistry Regents exam. In this video, we're going to go over Part A, which are all multiple choice questions. Let's just get to it. Usually, Part A are the easiest questions. They are essentially recall questions, information, hopefully, that you have memorized, at least for the time being. Not any math here, just information to process, and we have 30 questions. Let's do it. Number one, which description of the atom is based on the results of the gold foil experiment in the early 1900s? Hopefully you would remember two major conclusions from Rutherford's experiment. One is that the atom has a small, dense center that's positively charged, and the other is that it is mostly empty space in atom. And sure enough, here we are at choice 3. For number 2, according to the electron cloud model, which term is defined as the most probable location of an electron in an atom? That is the definition of an orbital. The electron cloud model, whatever you want to call it, that is our current model for the atom. For number 3, which change occurs when an electron returns from a higher energy state to a lower? So we're going from high to low. When that happens, you have energy that is going to be emitted, which is choice 4. Nothing to do with ionic compounds. If an atom absorbs energy, then the electron moves to a higher energy state, but when it drops back down, it releases, which is emitted, or choice 4. For number 4, which phrase describes the different isotopes of an element? This is another classic definition. Same number of protons, different number of neutrons. Can't be number 1 because I see electrons in there. Can't be number 2. The word electrons is in there again. It is choice 3. Same number of protons, different number of neutrons. Question 5. Which statement describes a chemical property of sodium? A lot of times in this exam, they're not going to give you necessarily the element symbol. They'll give you the name. You have to do some work. If you don't know the symbol and you would actually need it, you can go to reference table S. Of course, the symbols are also listed on the periodic table. If we're talking about chemical properties, we're talking about reactions. And silver is a description. Density is a physical property, another description, if you will. The size of the atomic radius, physical description, it is choice 4. When you see the word reaction or reactive, you know it's chemical. For number 6, oxygen can exist as a diatomic gas or ozone. These two forms of oxygen have? Well, certainly they have different structures and therefore different properties. These are known as allotropes. The word allotrope is never used on the chemistry regents, but sure enough, there's always an allotrope question. So different molecular structure, therefore different properties, which is choice 2. For question 7, which formula contains a polyatomic ion? Now, if you have a polyatomic ion, that is a cluster of atoms together, there is a polyatomic ion table. All you're going to do here is play the matching game. Let's check it out. Here they are, the polyatomic ions in reference table E. And what we're looking for is one of these being in the formula for our answer. And it turns out it's going to be cyanide or CN. When we go back and take a look, you're going to see that as KCN or our answer. And sure enough, for question 7, that would be choice 1. The rest of them, you are not going to see any polyatomic ion on that reference table. For number 8, what information about C4H10 can be determined from its structural formula, but not determined from its molecular formula? Well, you got to know the difference, right, between the two. A molecular formula is what was given here. It gives you the different elements and the number of times the atoms of those elements are in the formula, but it doesn't give you the arrangement. The arrangement is coming from the structure or structural formula, which is here. For number 9, which quantity is conserved in all chemical reactions? There are actually 3: mass, energy, and the last one we forget about a lot, which is charge. It's a fact. You need to know it. Hey, I hope you're doing okay so far. If you're finding you're getting a lot of these wrong, what is going on is you don't know the vocabulary and the facts well enough. You should have some sort of review pages at your fingertips. I'll leave a link in the description of the website I have where you can go ahead and get some review sheets if you don't have them already from your teacher. And with that, let's keep going. For number 10, what do the coefficients in a balanced chemical equation indicate about the substances in that equation? Well, if you have a balanced chemical equation, you have, of course, the coefficients or the numbers in front of the formulas. That gives us our mole ratios. Your coefficients, again, are your mole ratios. And then when you look at a chemical formula, that gives you your atom ratios when it comes to compound. For number 11, which substance has metallic bonding? If we're going to have metallic bonding, we're going to have a metal. Now, the only thing that makes question 11 hard is you're not given the formulas. So going ahead and flipping to the periodic table to find those elements, right? 2/3 of the table to the left of the staircase on the periodic table, you're going to be able to pick up what metal it is. But we don't have that here. I'm going to just go ahead by process of elimination. Remember, you can go to reference table S, argon or AR, that's a noble gas. It's going to be listed all the way on the right-hand side. That's not our answer. Barium chloride, when you see 2 words, you have a compound. We don't have compounds when it comes to metals. So it's not going to be barium chloride, and it's not going to be sulfur dioxide. It is titanium. Now, reference table S, the symbol is Ti. You go to the periodic table, and sure enough, you're going to find titanium in the middle of the table. For number 12, how many pairs of electrons are shared between nitrogen atoms in a molecule? Now, if you were to forget how many pairs of electrons are shared between the two, if you go to the periodic table, nitrogen happens to be in group 15. Each nitrogen atom has 5 valence electrons. However, nitrogen wants to get to 8 because that's the noble gas configuration. What happens is there is a triple bond then between nitrogen atoms. So the pairs of electrons that are being shared are 3. For 13, which formula represents a molecule with an asymmetrical distribution of charge? For this, you can remember the word SNAP. And maybe your teacher mentioned this to you. If not, you could write this down. And then you put a line between the S and the N versus the A and the P. Symmetrical is nonpolar molecule. Asymmetric is polar. In other words, they're asking us which of the 4 is a polar molecule. And hopefully you always remember water is polar, which is choice 4. Question 14, given the equation representing the reaction, right, what's occurring? This is a 2-for-1. You got to answer whether energy is released or absorbed, and then you got to answer whether you're forming a bond or breaking a bond. Obviously, this reaction tells a story. You have I2, so it's bonded together, and now it's separate. So what happened is the bond was broken. I can get rid of 1 and 4, and notice I answered one of the 2 first. And then what happens when you break a bond? Breaking a bond is just like breaking a bone on your body. It is energy that is absorbed, which is choice 3. For question 15, the electronegativity difference between the atoms in a molecule of HF can be used to determine. Well, what electronegativity differences do is they tell us what's going on as far as the bonding between the atoms, which is choice 3. Also, for individual atoms, electronegativity tells us how much of a pull an atom will have on trying to get an electron. Alrighty, so 16, which sample of matter is classified as a mixture? Mixture is two or more substances that are physically combined. You're not talking one phase only, solid, liquid, gas, one phase only. It's got to be AQ. That means you have potassium nitrate or KNO3 and water. For question 17, which property of tungsten remains the same for all samples of tungsten? Tungsten, of course, it's interesting, right? It has the symbol W. It is an element. And what we're looking at here is if I had a little bit of tungsten or a lot of tungsten, what's the same? Certainly a little versus a lot. It's not the mass. It's not going to be the surface area. It's not going to be how much energy, because maybe I have one in my hand and my hand is warming the tungsten and one is on the table. It's going to be density. For 18, an element is composed of atoms that must have. The identity of an atom is based on one subatomic particle only, and that is going to be the number of protons. The number of protons, I call it the element's social security number because it's always the same, and that is the atomic number, or choice 2. For 19, compare 0.2 molar solution of Ki at 1 atm. Hold on. For question 19, compared to a 2.0 molar aqueous solution of Ki at 1 atmosphere, water at 1 atmosphere has. We got to watch the wording here. This is what we call a colligative property question. In other words, I'm drawing a really bad thermometer here. I got my boiling point here. Water, you know, boils at 100. Freezing point down here on my thermometer. Water freezes at 0. That's if it's pure water. As soon as I have something dissolved in water, in this case Ki, we say the boiling point goes up and the freezing point goes down. Now, we just got to watch the wording. It says compared to a 2 molar aqueous solution of Ki. The water then will have a lower boiling point and a higher freezing point. And let's see, which one is that? A lower boiling point and a higher freezing point, which is choice 2. It's really a wording question with 19. Checking out question 20, which statement describes the particles of an ideal gas based on kinetic molecular theory? There is no such thing as an ideal gas. It is a gas that follows a model that humans have come up with. And in that model, we're saying that ideal gases do not take up any volume on their own, and they have no attractive forces between them, and a couple other things. So which statement describes the particles of an ideal gas? That the particles have attractive forces? No, that's for real gases. Ideal, we're saying they don't. That particles move in random, constant, straight line motion? That is our answer. We don't talk about energy being lost regardless of the collisions, and we don't talk about particles knocking into each other, knocking into the walls, all that kind of stuff. So it is choice 2. Once you got your answer, don't go any further. For 21, chemical reactions are most likely to occur when reacting particles collide with, well, they have to have enough energy and essentially are coming in at the right angle, also known as orientation. And sure enough, that is going to be choice 1. It's got to be both energy and orientation, because we got to break those bonds in order to be able to form new bonds. Question 22, at STP, a 2-liter sample of nitrogen gas and a 2-liter sample of oxygen gas have to have the same. Well, they have the same volume, temperature, and pressure. That means that they have the same number of molecules. This goes back to, again, the gas topic that you went through and studied in your class. So far, I have not seen any surprise questions. These are all questions that have been used in some way, shape, or form on many Regents exams, and that's why it's so important that you practice questions on your own. Let's check out question 23. Based on table H, which compound has the weakest intermolecular forces at 75 degrees Celsius? Weakest intermolecular forces means that they're not going to have a strong attraction molecule to molecule. Let's go to table H and I'll explain. As you can see here, we're looking at the vapor pressure of only 4 liquids. And what do we have? We have vapor pressure, or pressure, right? As a liquid goes from that state into the gas phase in a closed system, vapor pressure here on the X, and on the Y rather, and temperature on the X. The weaker the attractive forces between particles, the easier it is to go into the gas phase. And that means that propanone has the weakest attractive forces of the 4, and ethanoic acid has the strongest. And that will always be the case. That means that the answer is choice 3, propanone. For 24, which term identifies a force of attraction that exists between molecules of water? Please keep in mind water is a polar molecule. You have polar bonds and you have polar molecules. But the electronegativity difference between the oxygens and the hydrogens in a water molecule make it such that there's very strong attractions from one water molecule to another, that we call it hydrogen bonding. It is an attraction, but that's the label that's used. I know it can be confusing, but that is, I call it the super duper dipole-dipole attraction. For 25, which process results in an increase in disorder? Now, disorder is related to a word, entropy. You should have heard that in class. And what we're looking for is the more disorder, the further away particles, whether they're atoms, molecules, ions, are from one another. Of course, that means that if I have a substance that's going into the gas phase, or I have a solid or a gas that's going into water, aqueous, those would be an increase in disorder. Let's just go down the list. Condensation of water vapor. That means we're going from a gas to a liquid. That would be a decrease in disorder. Freezing of a liquid. That would be liquid to solid. That's, again, a decrease in disorder. Now, sublimation of solid iodine means we're going to be going from a solid directly to a gas. That is definitely an increase in disorder, which makes our answer choice 3. And just going over choice 4, solidification of melted sodium chloride, again, means liquid to solid. So once again, for 25, the answer is choice 3. For choice 26, for question 26, systems in nature tend to undergo changes that result in what systems like is they like lower energy and more entropy, which means disorder. So it's not going to be both. They don't follow one another that way. So we want an increase in entropy and a decrease in energy, which is choice 4. For 27, it's asking what is the general formula for a homologous series that includes ethyne. Now, homologous series just means that as I'm going and adding one carbon to an organic molecule, from the last organic molecule, it's actually one carbon and 2 hydrogens. It's consistent, hence homologous. Ethyne, YNE rather, is a triple bond in the molecule, and for the general formula, all you need to do is go to the reference tables. We're talking ethyne, the YNE ending, which here is that general formula, and you just play the matching game back to the question. And that is going to be choice 4. For 28, given the equation represented in the reaction, when 2 moles of electrons are gained by fluorine, how many moles of electrons are lost by iodine? Well, it's a balanced equation. You don't even have to really do anything here. It has to be an equal exchange. What's lost has to be gained. So 2 moles are gained, 2 moles are lost. For 29, which compound is an Arrhenius base? Arrhenius bases means that I have a metal and OH, which is choice 3. Now, if you weren't sure, you could go to the reference tables. There's a list of acids and a list of bases, and you could go ahead and process of elimination. Let me just show you something. For reference table L, you see the common bases, and the first 3 all have a metal and OH. The only one that does not is ammonia. That is because ammonia is not defined as a base under Arrhenius' theory. It would be the other acid-base theory. And you see calcium hydroxide there, which was our answer. Last question for part A, question 30, which statement describes the benefit of fission? Fission is a nuclear reaction. You should recognize that word, along with fusion and natural radioactive decay and artificial nuclear reactions. In the case of fission, that is the nuclear reaction that goes on in nuclear reactors that give us power. And there we go, right here. It's a benefit, nuclear power. That ends part A. I'm going to go ahead and do part B-1. There are 4 parts to the exam. You should do all 4, whether you're taking the Regents in August, January, or June. The main thing is practice questions. I also want to mention I do have a website that's Chem Coach Central. And if you take a look there, I have a whole review packet where you can read over all of the information, especially the definitions and facts you need to know going into the exam. No matter what, good luck and keep on working hard.